So yeah, hello guys. Am I audible?
Yes.
Okay, cool.
Yes.
Oh yeah. So today's session will be an intro to programming. Okay, so you don't need any prerequisites for this thing. Okay, all you need is N2. So we're gonna start with the very basics. So one important thing which I would like to request you all throughout the session is, if you have any doubt at any point of time, feel free to stop me or any other speaker and ask your doubt. Don't be like, my friend is not asking or nobody's asking. I'll not ask. They might also be having the same doubt and they might not be thinking the same thing. So make sure to ask your doubts whenever you have something. Right. Okay. So let's get started. Yeah. So we start with the most fundamental question. What is programming? So, let's see the dictionary definition first. The process of preparing an instructional program for a device. Okay, so this definition kind of looks slightly bookish and not really clear. So I'll try to explain it in more simple terms. So programming is basically getting your computer to do a specific task. And when you're giving instructions to the computer for doing the specific task, you have to be very, very precise. So we'll take an analogy with which this definition will become clearer. So suppose you have a friend, okay, and he has got a new Lego set to build. Lego set, those are those blocks, and you can build different things like cars, houses, and all those things. Most of us would have played with those building blocks to make houses and all that. Does anyone have a doubt? If someone is unmuted. Yeah. So you instruct your less than intelligent friend. So I didn't actually want to write the word dumb here, so I wrote less than intelligent. So he's brought a Lego set, and he has lost the instruction manual. Okay. So now he wants to build the house. You want him to build the house. So you need to give him instructions so that he can build the house. Now, while giving him instructions, you need to be very precise while giving him instructions, because suppose you can't just be like, suppose you're building a house, you can't be like, build the stairs, then build the wall, build the roof, build the floor, and your house is done. You have to be very precise. Build the staircase means, how do you build the staircase? You build each stair. How do you build each stair? Using a single block. How do you place the block? So you have to be very precise while giving him the instructions, because he on himself cannot take any decision. Everything what he is going to do is what you are going to instruct him to. And why you have to be very precise is that every piece has to go to its right position. Okay, so yeah, so suppose some piece is supposed to go on the staircase and it goes on the roof, then it's not really the output which you were expecting. So you want the perfect house at the end. So you have to give him very precise instructions. Now this is exactly what programming is. Okay, so giving instructions to your friend is very similar to how programmers write code. Okay, now computers are dumb. Now this might seem like a very controversial statement to many of you, but it is actually the case. The thing is that the magic which is done by the computers, like you're seeing this on a computer, maybe on a phone, laptop, iPad, or whatever. So you're saying computer and I'm saying computers are dumb. How does that make sense? The thing is that the person was programmed your interface, programmed Microsoft Teams and all these things. That thing is enabling you to see me and listen to this lecture. So as such, the magic is not in the computer. The magic is in the hands of the programmer who's writing the program. So when you play a game in your phone, and you see all those graphics and the shooting games and all that. So the magic is not of the phone. See, the phone is doing what the programming is asking it to do. So the programmer gives a very set of precise instructions. It tells, okay, if somebody presses the right arrow, move 2 steps to the right, then it'll function exactly as it is supposed to. Else it will not, and the desired output won't come. So this process of giving instructions to the computer is really what we call programming. They appear to be smart because we program them in such a way. A computer's main functionality, is from how we really program it, from how we really manipulate it to serve our needs. So yeah, is this definition of programming clear? Obviously you're sitting in a session of intro to programming. So I guess you need to understand what programming is. So is this thing clear? I mean, the session would be better if it's more responsive. Any doubts here?
No doubts.
Okay, cool.
No.
Yeah, thank you. Yeah, it will be better like if people are talking like this, it'll be more interactive. Okay, so yeah, that is what programming is. Now, what is the language of code? Okay, so whatever code we are writing, so how does the computer understand? Does computer understand English, Telugu, Hindi, or what? Or does a computer in Chennai understand Tamil and a computer in Hyderabad understand Telugu? How does it work? So turns out that computer doesn't understand any of these languages, unfortunately. So what they understand is something called machine code. So what is machine code? Now machine code is basically a sequences of zeros and ones. Okay. Now these zeros and ones, suppose you as a human see, you'll feel them to be really cryptic. But this is actually the language of the computer. So everything. Now you are seeing, you play games, you now say Microsoft Teams, it's working, it's functional. Somebody would have written some code on it. Now ultimately this will be getting converted into a sequence of zeros and ones. Everything you do in a system is associated with a sequence of zeros and ones which the computer understands. So suppose you click a button. For such a simple functionality also, there will be some encoding to zeros and ones which will make the computer do some specific task. Okay. Now as the zeros and ones are cryptic to us, like say I give you say all the zeros and ones, the functionality required for say working of a game, you won't understand anything. The same way, all our real languages like English, Hindi, and all that is for a computer. The computer won't really understand any of our languages. So, taking an analogy to the Lego example, it's like your friend only understands one language. Say he only understands Tamil, and you only understand Hindi. So, for you to give him instructions, either you have to learn Tamil or he has to learn Hindi. Now, obviously, the computer is not going to come and learn our languages. So we somehow have to learn machine language or convert whatever we are writing or whatever language we are instructing to machine language. It's actually very difficult, very boring, and very laborious. So, it'll be completely impractical for people to sit and convert English instructions to machine language. So then how do we interact with the computer? So we do this using the help of programming language. So a programming language is, kind of like a middleware. What happens is you write in a programming
Sorry to
language.
interrupt.
Now, yeah.
Sorry to interrupt. Like voice, I want to know whether it's breaking for me alone, like or it's for everyone.
Okay. Oh, is the
Your
voice
voice.
breaking? Okay. Is the voice breaking?
No, it's clear.
Okay. It's clear for everyone, right?
Oh, it's not breaking.
Yeah. Okay. Cool. So I guess
Okay, I'll check my
probably
network.
log out and log in again, or just check out your internet. Yeah. Okay.
Yeah, try.
Not clear, not clear.
Okay. The voice is not clear. Is it breaking?
It's clear.
Okay. Fine. Cool.
Yes, it is breaking.
Okay. I'm confused now. A lot of people are telling it's breaking and it's not clear. Okay. I'll probably log out and log in again. Probably, if it's the issue with a lot of people, then it'll probably get rectified. Yeah. Just a minute. Yeah. Is my voice working fine now?
Yes,
Yeah. Okay. Cool.
it's fine.
Yeah. Okay. Right. So yeah. Sorry for the break
Excuse
info.
me.
Yeah.
Yeah.
Sorry.
Will we get the PDF of the slides after the
Yeah.
lecture?
You'll get the slides. Yeah. You'll get all the slides. You don't have to note down anything. I mean, nobody can stop you from noting down. But it's better if you focus on just understanding.
Okay. Thank you.
Okay. Yeah. Cool. Cool. So yeah, programming languages. So they kind of serve as a middleman. So what they do is, now programming language is something which can be understood by humans. Now suppose currently you might not be knowing a programming language, but learning a programming language is much easier than learning the binary coding. So what people do is, we learn programming languages, and there are tools which convert the code you have written into machine code. Now that machine code is executed by your computer, and you get the required output. So this way both the tasks are being done. It's not difficult for the human, because learning a language is easy, and the computer is also getting the machine language. So it kind of serves as a middleman, translate your instructions to machine code, much easier for humans to learn and understand. So exactly what I told. You write in programming language, it gets converted into machine code, and the machine code is executed by the system, and you get the output. That is what a programming language does. Now, a simple characterization, high versus low level languages. Now, I mean, I just thought to put one characterization. They're very different types of characterization. So this is basically, based on how close the language is to the machine code. So now see, when you write a program, there are two things which is happening. One thing is, the program which you're writing is getting converted to your machine code. Next, your machine code is being executed by your system. Okay. So how similar your language is to your machine code is basically the level. So lower the level, more similar the language to the machine code. So if you take something like binary, that is like exactly machine code. So that is completely similar to machine code. Next comes, there's something called assembly. Now assembly in itself is very cryptic, but people do program in assembly. Okay, so converting assembly to machine code is really, really fast, because it's very close to machine code. And then comes C. Now many of you might be doing C now, because of the there's a code CS1100. So that is also one of the fastest languages. That's a very low level language. Then comes C++. Now you have high level languages like Java and Python. Like if you see the interface of Python only, it's all the commands are pretty English like. So it's more easy for the developer to do things. So slightly farther from the machine code. Now, what impact does this low level and high level have? The thing is, when a language is low level, now as I told you, there are two things. One thing is conversion of the whatever program you have written to machine code, and execution of the machine code. Now, for a given program, execution of the machine code will be same. The time required for the execution will be same. Now, the only thing which changes as far as the execution time is concerned is the conversion. The conversion from your programming, whatever you have written, to the machine code. Now, if it's low level, the language is closer to machine code. So the conversion will happen faster. So the language in turn will be faster than high level languages. So lower level language programs are faster than their higher level analogs. Okay. So yeah, is this part clear till now? Machine code and programming languages. Or any doubts in this? If you have any doubts, feel free to ask. Is this part clear? I guess there's a reactions thing also. You can put a thumbs up if it's clear. Can I see reactions? Yeah.
Like Python, or like Python interpreter, or like literally in C, like what is C actually written of?
Okay, so what happens is, a lot of these interpreters are actually written in more low level languages, like say a lot of libraries in Python, they're actually coded a lot in C. Like you say two big libraries like NumPy and Pandas. So these both are libraries extensively used in data science. So these primarily 90% of this is coded in C language. So many of these interpreters and compilers, they're written in lower level languages which again, for compiling those lower level languages, there'll be some other code. So ultimately, it's just a chain and it gets goes to the machine code. Was that your doubt, or did I understand it wrong?
I mean, like, it all like, I know, like Python is written in C, but like, what's like, C is made of?
Okay, so C will be made of something more fundamental, perhaps assembly. I'm not really sure about that. Now, again, the question comes: how is assembly made of? How is assembly, converted to machine language? So I'm not really sure of that. I probably try googling it. I've never thought of that thing, so I'm not really sure of that. Just try googling once. Yeah,
Yes,
I mean,
okay.
I couldn't answer your question. Sorry for that, but like I currently don't know.
Yeah, like, no, no worries.
Yeah, okay, no issue. Yeah, any other doubts? Okay, cool.
What?
So,
Sorry?
any other doubts?
No doubts, no doubts.
Okay, yeah, okay. So where do we write code? Now, the thing is that you can't just write, code in some notepad and say, suppose you want to add two numbers, you can't write code as you open a notepad file, write add 5 plus 3, and you save it, you'll get the output. So that is not how things can be done. So what you need is, as I told you, that when you write the programming language has to be converted into your machine code. So you need some set of tools for that. Okay. So what happens is there's something called an IDE. What an IDE is, an integrated development environment. Now what this thing is like a package which has all the tools. So what you do, you go to the IDE, you just simply write code, you run the code, and you can see your output. You don't have to worry about getting some extra software or thinking about how to convert the programming language, the programming code you have written to machine language. So IDE is a place to write, run, and debug code, and also convert it to machine code. So what you can do is you can write your code, you can run your code, and debug basically means a bug is some error in your program. So suppose you wanted to write a program to multiply two numbers, but you are in turn adding them. So there's some bug in your program. So the correction of those bugs, the removal of those bugs is called debugging. So an IDE helps you to debug. So, and as I told you, the tools are there. So those tools convert it to machine code. So they're exactly like you have your file explorer, notepad, any game. They're exactly like that, but they just help in code writing. So I can probably show you 1-2 IDEs. So one is Visual Studio Code. So what happens here is, suppose I open a file here, I can write my code here, I can run my code using this, and whatever output I see is here. So this is one type of IDE. Now I don't have to worry about how things happen internally. Okay. Now another IDE, as I've written Sublime Text. So these are different type of IDEs, multi-purpose IDEs. These both are, you can pretty much run any language. So I have just, for example, I've written some code here. I can run my code. I can see the output. I don't have to worry about anything what is happening in the middle. It's kind of like an abstraction for me. I don't care about that. I just care about writing my code. So, IDEs have made that in a very well way. Now they also have built-in error checking. So basically, suppose there's an error. Suppose you've written 1,000 lines of code, and there's an error. Your code does not work. Now you don't have to read all the 2,000 lines again. The IDE will pinpoint the exact line where where the grammar is not matching or what issue is happening, and then you can try to rectify your error there. So that is something which is helpful. So that is what IDEs are, basically where you write code. So now learning a language, which you are, this is the first session of a series of 4 sessions. So you are going to learn, the basics of some or the other language in the next session. So one very important thing is, every language has its own rules, like there are rules in English language or any other language. Those rules in a language are called grammar. So when you speak, you are expected to follow a set of rules called the grammar so that the other person can understand. And the same goes with programming languages. But there's one difference here, that suppose, I make a grammatical mistake in some sentence. You'll still understand it because, our minds have been programmed that some mistake here and there, we can understand. But that's not the case with computers. You have to be very, very precise. As I told earlier also, everything which you're doing should be very precise, because the computer on itself cannot think anything. Okay, so we need to follow the rules. Syntax is basically the rules. Whatever, the grammar in real life is called a syntax and coding. Since computers are dumb, so you have to follow those grammar rules very, very precisely. Okay, suppose there is some precise way to write instruction. You cannot just change some things and understand. Okay, it's just almost similar. The computer will understand. You have to be very, very precise while doing it. And those rules are called syntax. And if you break the syntax, you'll get an error. So you'll have to again rectify those errors by removing those syntax issues. Okay, so is this part clear, or any doubts in this? How do I open this? Yeah. Any doubts in this? What we have discussed, IDs and writing languages, syntax. The idea of being precise to a computer. You can you put a thumbs up if it's clear. I guess that way I can see some thumbs ups or no thumbs ups. Its reactions is at the top of the screen. So yeah, I can see a hand raised. Any doubt?
No doubts.
Okay. Yeah, cool. So beside the hand raise, there are thumbs up, heart, clap, I don't know, a lot of things like that. So yeah. Oh, anyway, yeah. No doubts, right? Okay, cool. Okay, let's move ahead. Now, how do we get information from computers? Now, what we are really trying to do is, suppose suppose we write a code to add two numbers. Okay, so we write the code. Suppose the input is 4 and 3. So the computer has done the job. It has internally it has 7 in it. Now we need to somehow have a way to see the output, or else there's no point. We don't know how whether the code is working or not. Think of it in this way. Suppose you want to solve a problem. Somebody comes and gives you a code and says, take this code and solve the problem. Now, the way you can be guaranteed that it will solve the problem is if you run the code and you can see what the code is outputting. So by this question, I mean, how do we really see the output? So we see the output as a place called console. Okay, now I can just show you the console in places, some IDs. Like, say this is an ID. This is called Sublime. So this part is the console. Okay. So suppose I run something, I'll see the output out here. Now in my case, I've done some customization, so I'll just see it here. But if I just download Sublime from the internet and I run my code, I'll see the output out here. And there's a similar thing in other languages also. Like VS Code, there's something at the bottom. This part which you see is really the console. So suppose I run some code there and I output something, I can see it on the console. Okay, so what you can do is for printing something to a console. Okay, this is the next slide. Yeah, so the main use, console can be used for different purposes, but the main use is the output text. So you need to use the print statement. Now this print coincidentally matches with the Python print also, but it's a very generic print. So you need to use a print statement to output whatever you're doing, to show, to see the output. So using a print statement which can see the result. And this print statement depends on the language. Like as I told you, there's a set of rules for every language called syntax, and this syntax varies with language. Like in C it's called printf, in C++ it's called cout, in Python it's called print, in Java it's called system.out.print. And another interesting thing, suppose I open Google out here. There's actually a console here also. So why this console is, you can actually run JavaScript out here. Now, how you can access this console is just right click, click inspect. I'm sure some of you would have tried this, tried changing Google to your name out here or something like that. So there's a console out here on the Google website also, or any website you go. So in JavaScript, the way to print something is console.log, and you write whatever you want to write. Suppose I want to print hello, it just outputs hello. It's a very similar thing in other languages. To print something, you write the corresponding print statement in the respective language, and then you can see this. Okay. So yeah, so that is about printing. Now, what can computers do? So we told that computer is a dumb machine. Okay. How dumb is it? Can it not do anything at all? Do we have to code everything in it? Sometimes it can do a few, simple things, which, which we'll be using many times in our programs. So they know how to do simple arithmetic, that is addition, subtraction, multiplication, division, and all. So you suppose you want to add two numbers, you don't have to write a code to add two numbers. You can just add a plus b or 2 plus 3 and it'll add them. Okay. You don't have to write a custom logic, to add the numbers. Same goes for the other fundamental operations. Okay. Now you'll be able to print the result of any math operation also. So something like print 3 plus 4 will output 7. Now you'll be thinking, what's the use of this? I can just, take my calculator and do 3 plus 4, 7. Why do I have to write code for that? So yeah, I mean, that's a valid point. But the thing is, when somebody is designing a software, say for example, you're making a calculator application. Okay. So you want the user will input two numbers and, say an operand, and you'll show the output. So in that case, you have to take and you have to show the output also. So, and many times in debugging, you have to also, print the result of the intermediate steps to see what is happening. So printing does come in hand many times. So yeah, this is also another aspect. For example, we would need to utilize this functionality in order to display the answer when you build a calculator app. Okay, so this is what computers can do, in arithmetic. Now there's something called strings. Now a string, in very simple terms, is just plain text. Okay. So you open Notepad and you type anything. Whatever you type is text. You type 1, 2, 3. 1, 2, 3 is also a text. Now you might argue that 1, 2, 3 is a number. How are you calling it a text? How are you calling it a string? We'll come to that point in the next slide. So everything, whatever you write, any text you write, any character you write, that becomes a part of a string. Okay, so strings are basically text. Now, one other fundamental operation, these are some examples, anything enclosed within quotation marks, these double quotes is a string. Now, one other thing computers can do fundamentally is concatenate strings. Now, concatenate is basically club two strings. So, suppose I make this hello and I make world and I concatenate them, I'll get this hello world. Suppose, say this entire sentence is there. Suppose the first part of the sentence is one string, second part of the sentence is another string. I can concatenate them directly and I don't have to write custom logic for that. So suppose something like hello plus this word will concatenate to give me this hello world. Okay. Now I was speaking of a difference last time. So I think 1, 2, 3 is a string when you write on the notepad, but it's also a number. Now how can one thing be one thing can be both a string and an integer? So the difference comes in these quotation marks. So anything you enclose within quotation marks is a string. If you don't enclose in a quotation marks, it's an integer. Now you might feel, there's a very fundamental difference, just quotes. But again, you have to be very precise while giving instructions to the computer or else it won't understand. Say for example, you want to evaluate some arithmetic expression like 4 plus 5 minus 3 by 2 and something like that. You can't, suppose you have to use this thing. You can't use, string 4 into string 2. This will give an error because the computer doesn't understand how to multiply two strings. Okay, so this might not seem a big difference, but we need to be precise while writing code since computers are dumb. Okay, now variables, yeah. So this is again another part of the lecture. So before that, again, I'll come here. Any doubts? Any doubts in anything? Feel free to ask. I mean, this kind of theoretical, so you might feel bored, but we'll come to the coding part very soon. Any doubts? Okay. Okay, everybody's clear with it? You can put a thumbs up or any reaction. Okay, cool. Okay, people are listening. I thought again nobody will react. Right. Okay. So we'll start with variables now. Variable is something which can store information. Okay, now let's understand the idea of variables. So what a variable does is a place where you can store information. Now you can use this information again and again. Okay, so that can be referenced and manipulated. Let's understand both these terms. So a variable is something where you go and store information. What is referenced? Referenced means you can use that variable anytime ever. Why? I mean, there's no point in defining a variable when you cannot use it anymore. So you can use it, so it can be referenced anytime and it can be manipulated. So suppose you have some variable which is storing something, and say tomorrow you want it to store something else, you can do that also. Now I'll go with an analogy. Now this analogy will follow all throughout variables. So this is gonna be an important one. So try to understand it. So you can think of variables like cardboard boxes. I mean, like those things. If you go to Primark, you'll see those boxes which will have some will have ice cream somewhere, some will have chips. So those cardboard boxes. Now in those boxes you can store objects. So those objects can be changed. So in a box of ice creams, you can remove the ice creams, and you can put chips. They can be replaced. You might replace a faulty product with a new one, modified. Suppose you want to add something, you can do that also. It's kind of like a cardboard box used to store objects. Now variable is exactly that, but it stores some amount of information or data. Now each variable, so what happens is a variable has a name and some information associated with it. So it's like the box is there, the cardboard box is there. You stick a label to it. Okay, you stick a label saying that this is cardboard box 5. So suppose you have 100 boxes, okay, and you have labeled them cardboard box 1, cardboard box 2, and so on. So if you want to tell someone, you can say cardboard box 6 has ice creams and cardboard box 15 has chips. So giving a name to variables, helps us to identify them in a better way. So one thing is the name, and one thing is what is stored in there. So as I told, cardboard box 5 has ice creams. So ice creams is being stored in the cardboard box. So that is the content which you store in the variable. Okay. Now why are variables so useful? Okay. So what we were really doing till now is, we were doing print 2 plus 3, print 5 plus 6. We were really dealing with constants. Now why are variables important? The thing is, you want to make your program as general as possible. Now, when you use constants, your program will be solving, for solving a problem for a very particular case. Okay, and you cannot verify the correctness of your program just by that case. As an example, suppose you want to say write the code for suppose you're given two numbers a and b. You want to write the code for a power b. So what you need to do is, suppose the code you've written is a plus b, but your inputs a and b are 2 and 2. Now in both the cases, your output will be same. 2 square and 2 plus 2, both are same. But saying that your code is right is inappropriate because your code is wrong. And you cannot verify the correctness based on just a single case. So when you get variables, what happens is you write a general code. You have something which is variable, so you can, the user can maybe input those things and check the output and, verify the correctness. It becomes, yeah. Any doubt? Okay. So the user can, input values and you can see the output. It solves a more general problem. And also another thing is, you can change variables. Just think of it as, suppose you're playing a game, okay, and the game has, say, some health mode, okay. So suppose your health is 0, you die. Now suppose you hit something, you hit the wall, say, your health should reduce by 1. Now this is actually, you see, at every point of time your health is not constant. Suppose you hit an obstacle, your health should reduce. So that can be done by a variable. You cannot just store a constant in terms of health, and you cannot basically change constants. You can't make 30 equals 29, but you can make health as 1 less than what it was before. So using a variable there will help you, modify it in a proper way. And again, the reference part, as I told you, you can use the variable always. The other important use is, taking input from the user, because see, you can write some cases, but suppose your code is taking input, say take calculator program, your user has to give input. So those things have to be variable. You cannot fix. You cannot be like, my code just shows 2 plus 4 equals 6, so I've made a calculator program. Your thing should be, you give me any two numbers A and B, will output A plus B. So it will take input. Making your program have variability, basically making it more general. Okay, have it change. We'll come to this now. What happens when we define a variable? Now this is an interesting concept. So when you define a variable, so okay, think of the memory. Okay, every system has some memory where you're storing things. So think of the memory as a space of long cells. Okay, so something like, just you take a rectangle, you break it, say a 1 cross n rectangle. So every piece of it is a cell. So what happens is when you declare when you define a variable, some space is given to the variable where it's like suppose you define a variable A, okay, and the computer says, okay, variable A, cell number 150 has been given to you. So whatever contents will be stored in you will go to cell number 150. Now if somebody wants to get the contents from you, he'll go to cell number 150 and he'll get it. Any doubts? Okay, we heard some disturbance. So yeah, that is the thing. Taking an analogy from the cardboard box again, it's like you have your own storage facility. So suppose somebody tells, make a new box, with label name and value programming. So what you'll do is you'll take a new cardboard box, you'll put it in the storage facility, you'll put a label on it saying name. Now here the name of the variable is name only, and the text contained in the variable is programming. So you'll take a piece of paper, you'll write programming, you'll put it in the box. So suppose somebody tells you, tell me the value of the variable name. So you'll search for the variable, search for the box with the label name. Suppose you found this is the box. You open the box, you see the text in it, and you be like, okay, the text in this box is programming. So the value of the variable is programming. Okay, so that is how variables work when you define variables. This is exactly what a computer does. The storage facility is the memory. The box is a variable, and the contents of the box is whatever you want the variable to be equal to. This is the exact example which I gave. Okay. Now there's something called an empty variable. Okay. Before this, again, we'll ask for doubts if anybody has any doubts. Any doubts? Anyone? Or you can put a thumbs up if you don't have any doubts. Or any emoji.
Why is the name variable given to it?
Okay. So thing is that it's like what does the word variable mean in English? It can change at any point of time, right?
Yes.
So that's exactly the purpose of a variable. Suppose a variable has the name. Yeah.
It changes with time.
Yeah, it changes with time. The value contained in the computer science variable can change with time. And so since the value in the computer science variable, the variable which I discussed, is variable, hence the term comes. Like you don't have to fix the value there. You can change it, you can modify it at any point of time.
Okay.
Yeah. So empty variable, it's very simple. It's like it's exactly the same. You take a box, you put a nameplate on it, but you don't put anything inside the box. It's like putting a blank label. You're not putting anything inside there. Just put a blank label and you put a name. Now, why you would do this? You'd be like, why do I want to waste memory by declaring empty variables? The reason you would do this is, first thing, you're going to use the variable somewhere down the line. Okay, suppose you're writing some 100 lines of code. You want to declare all the variables initially. Now, initially there'll be empty variables, but as you write the code, you'll be using those variables. So some data will be going in there. And another thing is taking input from the user. So before taking the input, you define the variable. Now the variable is empty. It has nothing. The user will give some data which you'll put in the variable. So that is where an empty variable will come into picture. Okay. You're going to store some information somewhere later and store the information, basically input information given to you by the user. Those are the uses of empty variables. Now updating variables. Now again, this is something important. So how do you update variables? So what you do is, we'll take the cardboard box example again. So suppose somebody tells me, suppose our cardboard box name is age now, okay, whose value is 18. Now you have celebrated your birthday and hence want to update your age. You want to make it 19. So somebody tells me, update age value to 19. Now what I will do is, what the computer will do is, the cardboard box with value age, with name age, will search all the boxes. Okay, this cardboard box has the nameplate age. So what it'll do, it'll open the box, it'll take out the paper from it. The paper has 18 written in it. It'll erase the paper, it'll write 19 in it, and it'll put the paper back in the box. Okay, I'll repeat the steps again. Try to visualize it. That'll give a more better view. You search for the box with the nameplate age. Okay, you've got the box. Now you open the box. You remove the paper from that. Okay, the paper, you see the paper has 18. You erase the paper. You write the new value. Here the new value is 19. You put the paper back in the box. This is what exactly happens internally when you update variables. Now, how do you write it using code? A simple thing. You just call the variable and say equals to the new value. Like in this case, age is equal to 19. This is this will give the variable a new value of 19. This is exactly what I explained. You take the box, you put, you remove the paper, you erase it, you write the new value, and you can put the paper back in the box. Now observe that the position of the box is not changed. I never told remove the box from its place and do all this. So the box is still there. So the variable is still at that given cell only. So suppose it was cell 150, it'll still be at cell 150 only. The position is not changing, but the value in that position is changing now. Variable is simply a piece of memory, so we can easily update the numbers and their place will remain constant. So fate of variables. What do you mean by fate of variables? So what happens is, fate of variables, basically what I'm trying to say is what happens to the variables during the course of execution. So when you write your code initially, you write some say 10 variables. The computer gives space to all those 10 variables. Now suppose your code is done. The code is done, the computer will destroy all those 10 variables. The space will again be free so that any new variables can come in there. There's no point in keeping the variables again when the code is executed. The code is completely done. So there's, those variables will just occupy space there. It's just like you take the cardboard box example. So when the code starts running, you give 10 cardboard boxes their spaces. And when the code is done, you remove those cardboard boxes and you throw it. There's no use. Suppose you run the same code again. Again, 10 more cardboard boxes you keep. Again, the code finishes, you throw those cardboard boxes. You keep doing this for any program user. Right. After the code has run its course, variables are deleted in memory until you run the code again. And the program dedicates space for the variable again. Right. So at the beginning, as I told you, you make new boxes. After the code, you remove those boxes. You throw away those boxes. Okay. So yeah, we're almost at the end of variables. We'll come to the coding part in say 1 or 2 slides. So we have seen one way of manipulating variables. The box example where you take the box and you keep something in that and you keep the box back. Now there are other ways. One thing is addition, the basic operation. So something like C is equal to A plus D. So what it'll do is, it'll get the value at A, it'll get the value of cardboard A, it'll get the value of cardboard B. Cardboard B meaning the cardboard box with label B. It'll add those values, it'll store it in cardboard C. So you can manipulate variables in this way also. That you can add 2 variables and store it in a new variable and so on. Add, subtract, multiply, divide. You can do all the fundamental operations. And suppose something is a string. We discussed what a string is. So you can add. Add is basically concatenation. What we discussed that, hello plus world is hello world. That can be done in string variables also. Yeah. So we're gonna move to the next part. This is more intuitive part, the conditional variables part. So yeah, that'll probably be slightly more interesting. Any doubts till then in anything we have done till now? Any doubts? No doubts?
No.
Okay, good. Okay, so we move to conditional statements now. So what are conditional statements? So having your code do the same thing each time is boring. Okay, I mean, the computer is supposed to do the same thing again and again, but sometimes what you want, your code should not execute some part based on some condition. Think of it in this way. Suppose some game is there. So you ask the user to enter his age. Suppose the age is less than 18. So you want to have some discretion over your content of the game. The age is greater than 18. You don't want to have the discretion. So at every point of time, you're taking a decision. Suppose the age is less than 18, then you don't display these things. Else you display these things. That is what conditional statements help us to do. Depending on certain conditions, we want our code to do different things. If age is less than 18, we don't want to display, some things. Else, we'll display some other those things which we were not displaying earlier. So how do we write it? Okay, so this this session primarily focuses on something called pseudocode. Now, pseudocode. What is this pseudocode? The pseudocode is basically you're describing your algorithm the way you're solving the problem in pure English, normal English. So say whatever the code I've written here, if you write this code, say for any language, it will not work. Okay, you'll be doing the language specific, the syntax of the thing in the upcoming lectures. The second lecture is about Python, the third is about C++, similarly. So that time you'll be doing the language specific. Here what you'll be doing is the ideas. So the idea of a conditional statement. So then you will just go, you learn the syntax of that and you'll use it. So what is an if statement? What basically this is, if something is true, do nothing. Okay. If some condition is true, do nothing. As an example, again we go to the app example. If age is less than 18, don't display this part of the app. That is an if statement. So you're basically telling if this condition is true, then you do a certain set of statements. Okay. So each condition is evaluated as Boolean. No, again, this is a technical jargon. It's basically each condition is true or false. How do you get the true or false of this condition? Simple math. Suppose I say n greater than 2 and n is equal to 5. So 5 is greater than 2. We all know that. So that is true. Suppose I say n is equal to 1. 1 is greater than 2. That's wrong. So it is false. So just simple math will get you whether the condition is true or false. And then, we'll try to write whatever the statements are required under that if block. So whatever condition statements you're writing here, we call that as the if block. And if this condition is true, then these statements will execute. Okay. So if age is greater than 18, display those things in the app. So here the condition is if age is greater than 18. So age greater than 18 is the condition here. Now the user enters his age. Now suppose age is greater than 18. So that part of the app will be displayed. Now suppose user's age is say 15. So those parts shouldn't be displayed. So they won't be displayed. The control will never come under this thing at all if the condition is false. This is a flowchart. Flowchart is basically, it just shows the flow. It just shows the control flow of the program. So test expression is basically the condition. If the condition is true, you come to the if block. If age is greater than 18, if that condition is true, if block will say display those things. Else, you don't check this thing at all. You execute whatever is below. I mean, see, when you're write a big code, only one if statement won't be there. There will be a lot of things below also. So the below things will get executed as it is. So the if part will only get executed if the condition is true. Is the if statement clear? Okay, we'll do the if else statement, then I'll come to doubt. The if else statement is also, pretty intuitive. It's like if something is true, you do set of statements. Else, otherwise, the condition is false because the first block didn't get evaluated. You do another set of statements. So suppose maybe you want to check whether a number is positive or not. You write if n greater than 0, number is positive. else. When will this else block get evaluated? When the condition is false. So otherwise, some other statements are evaluated. So the else block will get evaluated if the condition is false, and the if block will get evaluated if the condition is true. So if n is greater than 0, n is the something which will come by the input, then you print number is positive, else the number is negative. What this code snippet will do is, I'll check whether the a number is positive or negative. Right, so that is the if else statement. We can see the flow chart also. So we have a start, we have an expression which is the condition. If it's true, it goes to the if branch. Else, if the condition is false, then it goes to the else branch. And then here stop is written, but if there are more statements, we'll execute those. So if and if else clear. If this is clear, I know pretty much I guess probably one more example is there, that'll be very clear. Any doubts on if and if else? How the flow is working or something like that? Okay. Right. So we have another type of thing which is called the else if ladder. Okay. What does this do? So the format is like this. You don't have to get scared by the format. It's very simple. What it says is, okay, suppose we take our grading system. Okay, I'll give an example with this. This will be clear. So you want to say that if the marks is greater than 90, grade is equal to S. Else, if the marks is less than 90 but greater than 80, then grade is equal to B. Else, if the marks is less than 80 but greater than 70, grade is equal to B. So if else, now when this will be helpful is if you have multiple conditions and you want to evaluate something if any of those conditions is true. So if condition 1 is true, now if this condition is true, it'll directly go inside this, then it'll go outside completely. It'll not even check these statements. If this is false, it'll come back here, it'll check this condition, the condition 2. Now if condition 2 is true, it'll go to this. So when will this get evaluated? If condition 1 is false. That is, it has not gone into the if block and condition 2 is true. Now if anything of this, nothing of this gets evaluated, the else part will get evaluated. If nothing above gets evaluated, the else part will get evaluated. Example, as I told you, the grade system, if something is, if the marks is greater than 90, then S. Else if it's between 80 and 90, it's A. Else if the marks is between 70 and 80, it's B, and so on you can go. And you can put an else at the end and you can print the last grade. That is the else if ladder. This is kind of the flow chart. You go to the first expression. If it's true, you execute the first statement. Else, you go to the second expression. You see the second. If it's true, you go to the second statement. Third expression, third statement, so on. You can have multiple else if you don't need to have exactly one. And ultimately, you go to the else flow, and whatever is get below, you just evaluate that thing. So yeah, you have an example here. Find whether, okay, I spoke this thing, but yeah, I would like you guys to try this and perhaps I don't know 1 minute, 2 minutes, then we can discuss this. Is the question clear to everyone? Okay, the first thing is conditional statements clear. All the if, else, if, all those things.
The question is clear.
Yeah. Okay. So you don't have to write any code. Just explain what you're saying. That is what we are really focused on this lecture. Just explain using if and else if, else whatever you have done till now. So anybody would want to give it a try?
May I try?
Sorry, I couldn't hear you.
Hello?
Yeah. Hello.
Okay.
So yeah.
What I would say is probably this. We have num as an established variable.
Mm-hmm.
We can say if num greater than or equal to 0,
Mm-hmm.
print num is positive.
Okay, right.
Else if, I don't think we need to print an else if because rest is only negative. We can just do an else and give print numbers negative.
Yeah, that's perfectly fine. So what we're really trying to do is, if num is greater than 0, greater than equal to 0, I just put these brackets for you to see. If print number is positive, else print number is negative. I mean, it's exactly like English. Somebody asks you number is positive or negative, the thought process that goes into your mind is what is written out here. Is this thing clear to everyone?
I have a doubt over here.
Yeah.
What if the input given is not a number? We have to like
Okay.
keep
So
a
yeah.
constraint over there.
Yeah. So well, I mean, that thing while giving the input, uh, you know, uh, the input is something which is very specific to the language. Okay. So you can, while you're taking the input, you can force the user to give a number as an integer only. Okay. So here we are, in this code snippet, I've never taken the input. So I'm assuming that the input is already taken.
So I can use else if over here, right? If and
Okay.
else if. So that only if numbers are given, I can get the value.
Okay. Yeah. You can use an else if out here. You can say that else if num is less than 0, number is negative. That will work perfectly fine. But what I'm trying to say is, you can force the user to give only an integer for this num. If the user
Yeah.
enters anything else, you can print like error, this is not this thing, or something like that. Is that clear?
Yeah.
Yeah, okay, cool. Yeah, so this will be the last example. So let's implement a calculator. So okay, I guess I should give this as homework probably. You know, probably people will tie it for more time, and the code is just here. So it's basic, a very fundamental calculator which adds two numbers, subtracts two numbers, multiply and divide. And divide means you have to take care of this condition. Let's say second number is not 0, a by b should not be 0. So the first number is in variable b, and the operator is stored in ch. So and you have to store the final answer in the variable ans. Also, one thing you can, the computer can compare things fundamentally. I forgot to mention that. So you can say that if character is equal to plus, then do this, something like that. So I would leave this as homework. Better try this at home. Anyway, the slides will be given, the code will be there, but I strongly request you to try this once. It's an interesting problem. Right, yeah. So with that said, okay, we have one more thing: usefulness of conditional statements. Pretty much what I discussed earlier, but I've just added a slide out here. So adds variability to programming. So if age is less than 18, don't display, else display. Now the program has become variable. It runs differently based on user input, what we would want it to happen. And now if the user, gives some input, we want to be able to adapt accordingly. These both points are exactly same. I mean, pretty much redundant points. And without any conditional statement, the program would run the same way every time. Suppose in our app example, we didn't have the check of age greater than 18. Any user, whatever age he enters, the same app will be displayed to him. Okay. So this is the usefulness of conditional statements. So yeah, with this, the teaching part is done. Just a small aside. There's this playlist by TEDit. It's called Think Like a Coder. It's a very nice animated series. So in case people are interested, you can surely go and look at it. It's not like 30-40 minutes video, it's like 5 minutes video. And it's not like a lecture, it's like a character is there, there's a backstory, and the character is trying to solve some problems. You use the concepts of programming there. So if you're interested, just go through this. It's a set of 10 videos, and the videos are like 5 minutes each. So with that said, my part of the session is done. So yeah, do you have any doubts in any part which I've discussed till now? No. Okay. We started with what is programming. We defined programming. We gave this Lego block analogy. We told computers are dumb, and we told we need to communicate only in zeros and ones. Computer does not understand English, Telugu, Tamil. Now this can be done by programming languages because we understanding zeros and ones is hard. So we write a programming language. There's some tools which convert the programming language into zeros and ones, and the computer executes it. We did a distinction on high level and low level. We talked about IDs, the advantages, and we can write code in IDs. Then we talked about syntax, rules, the grammar rules for any programming language, and the idea of being precise while doing it. We talk about printing something and the console. I showed you console. Even on Google. So in this website also, if I click Control Shift I, you can see there's a console out here. Now there are a lot of errors out here in the console. So the console can be used to display good things. So we talked about the console. We talked about that computers can do fundamental operations and string operations, that is concatenation. The important difference. We talked a lot about variables, gave the cardboard box analogy and used it in multiple places. So all these slides will be shared to you, and everything has been written in comprehensive way. So you can look through it. Talked about variables. Then we came to conditional. We discussed if else, and if else if. The else if ladder. You can have multiple else ifs here. You don't need to have necessarily one else if. We have given this, and this thing was given as in homework. So yeah, this. So that's it from my side. Any doubts you have in anything I've discussed? The next part you'll get a 5 minutes break here. I understand. 1 hour listening to something is hard. So any doubts? No doubts? Everything was clear? Okay. Okay then. I hand over the mic to Nivit. He'll be taking loops from here.
Hello everyone. So next we'll be covering a really interesting programming construct called loops. So before that, we'll take a short 5-minute break. So we'll start around 7:10. So yeah, just catch a breath. We'll get there. Hello, everyone. I hope you're back. Am I audible?
Yeah, you are audible.
Right. So I'm Nived. I'm a coordinator with the Analytics Club. So right now we'll be looking at a very interesting and powerful programming construct called loops. So I have tried to keep this very generic, so we won't be going into any form of syntax with respect to any language. So we'll understand it with some very basic examples. So throughout the session, so first of all, I'm sorry that this session could not be held offline because of the weather. A lot of us couldn't be on campus right now. The upcoming sessions hopefully will be offline. We have 4 sessions in a row for you guys. So in this session, we'll be covering loops. So first, we'll be discussing about why we need loops, the structure of a loop. We'll be going through the basic types of loops that we usually encounter, and we'll also solve some basic problems so that you can learn how to apply loops. So why do we need loops? So does anyone have any idea why we might need loops? You can just unmute and answer. Anyone? Okay, that's okay.
Like if
Yeah,
there's
yes.
if we are supposed to do the same thing again and again for a few times.
Yes, exactly. That is exactly correct. So basically, why do we need to use loops is to avoid repetitions and combine similar operations. So obviously, when you prevent repetitions, you also avoid long codes. So suppose I gave you the task of adding 10 numbers. So what could you do is something like this. You have just learned what variables are. So you can call a variable called sum and you can set it to 0. And then you can add each number to sum. You can say add number 1 to sum, add number 2 to sum, and keep doing this for 10 numbers. Now you can see that this code is already pretty long. It's 12 lines long. That's just for 10 numbers. So suppose you were in a situation where you had to add up, say, 1,000 numbers, then you would have to type out like 1,000 lines of code just for this. And the important thing to note here is that you're doing the same operation again. You're doing addition and you're doing it for 10 times again. Another scenario that we'll keep using in this session is we'll try to take this scenario where you want to open your lock but you've forgotten your password. So there are basically 1,000 combinations that you have to try out. So okay, so that's one situation where you might want to use loops. So when it comes to loops, there are a few things that you need to know. So before that, is there any doubts in why we need loops and where you might want to use loops? If you don't have any doubts, then if you could just say that or just reacting would also work. Yes, if you have a doubt, just unmute yourself.
No doubt.
Okay, thank you. Okay, so the first thing to know is iterations and iterations. So what an iteration is basically one performing the loop once is basically called an iteration. So that's like the technical term for one loop. And iterators are basically, they could be, there are multiple ways of defining iterators, but we'll just assume it like it's some kind of variable that will allow you to perform your looping statements properly. And there could be some conditional statements within the loop that might tell you when you want to stop the loop or for how long you want to continue the loop. And there could be some statements where you have to update the iterator. So okay, all right. So now going into loop logic, there are some things that we need to decide. So the first thing is, do we know how many iterations we need to expect? So for example, when I told you that we had to add 10 numbers, you knew that you had to add 10 numbers. So you can just basically run a loop for exactly 10 times. Or you might want to perform the loop until a certain condition is true. So that is when you want to decide a conditional statement for your iterator. And within each iteration, you need to do some task. So that is what operations do we want in an iteration. So in our addition example, we had to add, that is the operation. And in some cases, you might have to update the iterator. So we'll look at all these cases. So, okay. So the first type of loop that we'll be looking at is for loops. So for loops are generally used when you know the number of iterations that you want to perform. So the example here would be adding a set of numbers. So when I told you to add 10 numbers, you could use a for loop for it. Okay. So we'll now look at a small pseudocode for how we might do this. Okay. We'll get back to this. So for loops, we first we'll set a variable called sum to 0, and we'll repeat this for 10 times. We'll repeat a loop for 10 times, and in each loop, what we'll do is we'll add the corresponding number to sum. So that basically performs what we want to do. So we want to add these 10 numbers. We'll tell the computer do this 10 times, and at each loop, add the corresponding number to sum. So after this, you can return the sum. So this is how a for loop would work, because here you know that you have to do it for exactly 10 times. So for example, could anyone tell me how you could extend this to unlock the lock that we had before? So I told you we had to find the passcode to the lock. So it had 1,000 cases. So could anyone tell me how you would go about that?
You use a for loop inside a for loop.
Okay, can you explain it a bit more? For loop inside a for loop?
Yeah, then it's for like I equal to 1 to
No.
9.
Like I don't want like exact code of how you would use variables and everything. Just give me like a basic pseudocode level kind of thing.
Like for loop inside a for loop, which will first test for one value and then the next value, and so on for 1,000 times.
Okay, so yeah, that would work. So, but okay, so the way I would do this is basically it is
Sir.
a 3-digit loop. Yes, please. You can call me Nivet, sir. It's not required. Yes.
Yeah, we can use these 3 loops where we'll first fix the first number. For example, it will take
Yes.
1 as the first number. Then in the second
Yes.
number, it will take as the 1 as the second number. And the third, at the third place, it will go from 0 to 9. Then if it is not the passcode, then it will again start the loop from in the first digit as 1 only, and second digit as 2, and then again 0 to 9. And then as for second digit, again it will go till 9. If it's still not the password, then we can then the loop will change. For the first one, it will change from 1 to 2.
Yes, that is exactly correct. So yeah, but you have used something called nesting of loops. So we won't go into that today. So in a much more generic sense, what we can do is you can just consider 3 digits, right? So it's basically from 000 until 999. So you can for every time you can increase your number by 1, and you can put it into your lock and check if it works. And you do this loop for 999 times, and at the end of it, you will know what is your lock's password. So that's what we do. I hope that was clear. If anyone has any doubts, just unmute yourself.
Here the number of loops is not fixed, right?
In which one?
In
the lock
the
case?
case of lock, yeah, the number can be
Okay.
500. So what if I want to stop for the correct number? It had to check
Yes.
till the correct number, and it had to stop.
Yes, exactly. Okay, this is another type of loop that, called while loop that we'll be going into very shortly. So just give me 5 minutes and we'll get into that.
Yeah, sure.
So before we go into while loops, we'll just look at what a for loop logic look like. So the first step of any loop is basically to have an initialization. So initialization could be like some sort of variables or anything. So for example, in our adding 10 numbers case, we had to set a variable called sum to 0. So that would basically be our initialization. And now there might be a condition which, if true, we would do some processing. So in our add 10 numbers case, the condition was, have we completed 10 loops or not? And it's not really strict that only if the condition is false you stop. So in our case, if it was the case that we have not completed 10 loops, then we would do the processing. And if it was the case that we had completed 10 loops, we would stop. So, and if the condition is true, we would do some processing, in our case addition, and then we update our iterator, which is basically increase that we have that basically which basically tell the computer that we have done one loop. So that would be our update in this case. And if the condition is false, we basically stop. So that is for loops. If you have any doubts in for loops, you can stop me now.
Excuse me.
Yes, please.
Can you please show some example? Like
Example
show us coding.
of for loops. Hello. Like, do you want to
kind
see
of
like
live coding session or something?
like actual code of a for loop? Hello. Can you come up? Tell me a doubt again. I couldn't hear you.
Hello?
Yes. Yes.
Am I audible?
Yeah, you are audible. Please go on.
Yes. Can you please show some like live coding session or something?
Okay, I really did not have that plan right now. I'm not sure if we can do that. Like today's session is more of a generic introduction to programming session. So in the upcoming sessions, we will be going into the weeds for both Python and C++. So there you will be getting to know how to actually code down a for loop and a while loop and all sorts.
Okay, so this is just a theory session.
Yeah, this is just a theory. So this is just to get you started on how loops work and in which cases you might want to use loops and stuff.
Okay.
All right, we'll move on. All right, so the next type of
Hello.
loop is called, yes.
Hello, Nivit. Will we be provided with these slides, or should I take
Yes.
screenshots?
No. You will be provided with these slides. So yeah, everyone, I would advise you to not get stuck with making notes and perhaps just focus on the session. You will be provided with the slides. So and all the like questions at the end of the slides will also be answered.
Okay, thank you.
No problem. So the next type of loops that you will generally encounter is a while loop. So basically a while loop is where you would perform your looping action until a certain condition holds true. So for example, if you wanted to find the number of digits in a number, so can anyone tell me what would be the idea behind such a program? If anyone has any idea, you can just give me any random ideas that you might have. Doesn't necessarily have to be correct. Anyone? Okay, that's all right. So what we could do is we could do floor division by 10. So how this code would work is we would initially set a variable called number of digits to 0. So basically this variable will hold how many digits are in our number. So while the integer that we have is not 0, we will perform floor division of the integer by 10. So basically what we would achieve by dividing by 10 is that we would remove a digit from the integer from like the least significant bit, from the least significant end. So basically if you have a 5-digit number, if you keep dividing it by 10 for 5 times, you would basically have come to 0. If you have a 10-digit number and if you divided it by 10 power 10, you would again arrive at 0. So that is the logic behind this code. And every time we perform this integer division, floor division, we would increment the number of digits by 1. So that's it. So that's how we would find the number of digits in an integer. So here you can see that we are performing the looping action until a condition is met, until a condition is not met. So basically, if the integer is not 0, then we'll be performing these loops again and again. And when the integer becomes 0, we would exit this loop and we would return this number of digits, basically print it or whatever. So yeah, that's how our code works. If you have any doubt in the logic of the code or how while loops work, you can ask me now. And if you have no doubts, with reaction would also help.
So set number of digits is equal to 0 means what?
Okay, so basically, initially we are setting this variable to 0. Okay, and now every time we perform integer division by 10, we would increase it by 1. So suppose we had the number 300. Okay, so now initially we have our integer to be 300 and number of digits is 0. Now I perform floor division by 10, our number would become 30 and we'll increase number of digits by 1. Now we'll again do division by 30, division by 10, our number would become 3, but number of digits will be 2. And now still the integer is not 0, so we'll do one more iteration of this loop. So now our division of floor division would give 0, right? Because 3 by 10 is 0.3 and floor of that is 0. And the number of digits would have become 3. And now the integer is 0, so we'll have exited the loop. And so now we'll have the number of digits variable will hold the number 3.
Okay, got
Did you
it.
understand?
After dividing, we are getting closer and closer to the units place digit, and on the on increment of from 0 to the number, we are getting the number of digits.
Exactly, exactly. Any other doubt, guys? All right, I'll assume there are no other doubts. Okay, so this is what a flow chart for a while loop would look like. So again, once again, there is an initialization, but this time what we would do is we would go check a condition. If the condition is true, we will do some processing and in most while loops, you would see that there's no kind of updation of iterator or something like that. So you once again go and check if the condition is true. And when the condition becomes false, you would stop. That's when your loop ends. So that's how a while loop works. So if you have any doubts in while loops, why and how we use them,
What's the difference between the for loop and while loop?
yes. So basically a while loop, like I said here, is used to perform looping until a certain condition holds true. But a for loop, it is used when you normally know the number of iterations itself. So if you knew that you had to add 10 numbers, you can use a for loop. You can say do it for exactly 10 times. But here, in our case of finding number of digits of a number, you did not know how many digits your number has. So you can't say, I'll just assume it's a 5-digit number and do the loop for 5 times. You'll need to let the computer decide whether it is a 5-digit number or a 10-digit number. I think like that's the most basic difference between a for loop and a while loop. But the thing is, most for loops and while loops can be written in terms of each other. So you can write a for loop as a while loop as well. You can write a while loop as a for loop as well. I hope that was clear. If you have any other doubts, please ask. All right. So now we'll so like I told, for loops and while loops can be written in terms of each other. So this is the for loop that we had for adding 10 numbers. So can anyone tell me how you could write this in terms of a while loop? While a condition is met to something. Anyone? If you have any idea, you can just tell me. So I'll tell you how this is done. So basically, we would introduce another variable called an iterator here. So basically, I would set a variable to 1. So I am calling this the iterator. So now I know that I need to do this for 10 numbers. I need to add 10 numbers. So I'll say while the iterator variable is less than equal to sum, less than equal to 10, we would have to add the corresponding number to sum. I have actually missed the line here that should say that we need to increment the iterator variable by 1. So after adding the corresponding number to sum, we would increment the iterator variable by 1. So basically this loop would run for exactly 10 times. So you can see that for loops and while loops are just more or less just difference in a way we phrase the loops themselves. So they are almost more or less the same. So if you have any doubts, please, and you can tell me, and we'll be moving on to something interesting next. If you don't have any doubts, can you just put a quick reaction of thumbs up or whatever?
No doubt.
Okay, thanks. All right. So now we'll do something interesting. We will try to make patterns in the screen. All right. So basically, we want this pattern to be printed on the screen. So can anyone tell me how to do this without directly printing out this entire, like typing out this entire pattern? If you have any idea, let's make this more interactive, guys.
We can first make one, we can first type first line of stars, and we
Okay.
can define that line number as a variable, and we'll
Super.
apply while loop where that variable should the condition should be, it should be lesser than equal to 10. As soon as it will be equal to 10, it will stop.
Exactly. So basically what it says is this. So we'll basically set an iterator to 1, and we'll repeat this loop while that iterator is less than 1. And in each loop, what we'll do is we will display those set of stars on the screen, and we'll also move to the next line on the screen, because that's how the pattern is, right? There are like 6 stars on each line. And at the end of each loop, we will also increase iterator variable by 1. So what you can see is this loop runs for exactly 10 times. And in each loop, we will print this set of stars on the screen. So this is this is how we would do this pattern. So even here, you can see that we have kind of typed down 7 stars manually. So can you think of a way where we have to only say display star on the screen, and we could still use loops to generate this pattern? Anyone?
Then we have to use nested loops.
Yes. Can you tell me again? I couldn't hear you.
Then we have to use nested loops.
Yes. So yes. So this is a concept called nested loops, wherein you have one loop. So you can see a loop here, and this is a loop, and it is inside another loop itself. So basically, it's like nesting. It's one inside the other. So that's why it's called nesting. So outside, we have a variable called iterator1, which is set to 1. And we will repeat this process while iterator1 is less than 10. So basically, what iterator1 is our line number. So we'll do this for 10 lines is what basically the first loop does. And inside the first loop, what we'll do is we will set how many stars are we printing. So we have another variable set to 1, and we need to print 7 stars on each line. So we will perform this second loop for 7 times, and in each loop we will display a star on the screen. And in each loop we will also increment the iterator 1 and iterator 2 by 1 as well. So do you get how this works? So maybe I'll show it on the pattern. So basically, when you're here, the second iterator variable is set to 1. It jumps to 2, jumps to 3, jumps to 4, 5, 6, 7. Now it has reached 7, so it'll go to the next line. Again, but still the line number is still just 2. So it'll again do the same thing until the line number becomes 10. So the line number becomes 10, and when our number of stars becomes 7, it exits the entire looping construct, and now we are done with the pattern. So that's how this second solution would work. I hope you guys understood that. If you have any doubts regarding loops.
How to check which loop is more efficient?
Which?
Loop is more efficient, like which method is more efficient?
That is actually like this. Both these solutions are equally efficient. It just depends on how much work you want to do. Like here, you have like printed out 7 stars on your own, but here you have kind of done even that using a loop. So basically depends on how much you are willing to do. And here the code does become longer, right? Because you can see here there's only like 5 lines of code, but here you've got like some 8 lines of code. So it just depends on how much you want your code, what you want your code to. Any other doubts? All right. So now I have some questions for you guys. So can you tell me some way in which we can find if a number is prime using loops? Anyone can just give me any idea that you have. Doesn't even have to be correct. If you have any vague idea as to how we can approach this problem, please speak up. Anyone, guys? So, right, so maybe I'll just stop here. So you can think about these questions. So I also have some other questions. So you can try to make this pattern as well. So this is interesting. It's like a triangle. You can think how we might want to make this one. And we can also try to generate the Fibonacci sequence using a loop. So this is really interesting. All right, so that was the end of loops. So after this, there's another part to the session. You will be learning about arrays, a really interesting programming construct that is really powerful. It's used in all case of scenarios. So yeah, stay tuned for that. Thank you, guys. Yes, if you have any doubts.
Hello. Time complexity included in this 4-day session?
It is not included today, but you might get to learn about it in the other sessions. So today is actually like a really beginner level session for people who are not introduced to any kind of programming to just get started. So today we'll be covering really generic programming, just basic abstract ideas of what programming is, how it works, just basic loops, if else, arrays and stuff. So I'll be followed by Anirudh, who will be taking up with arrays.
Yeah. Hello, guys. Am I audible?
Yes, you are.
Yeah. So, I mean, just a small update. Apologies, we'll have to end the session here today due to the unreliable power and session actually extending bit beyond time. We're sorry if you expected to see arrays. We'll do it tomorrow. I'll be starting with arrays tomorrow. But yeah, I think we'll be providing the recordings for those who are not able to continue with us through the entire session. But yeah, apologies again. I guess this is something that's beyond control. There's underlevel power both in at